Hello, welcome back. Last class we had seen convolution between two different signals. So in which we categorized linear convolution and circular convolution. Linear convolution is very simplest one, and circular convolution we need to change the built-in function from CONV into CCONV. There is only one difference between linear and circular convolution when we using MATLAB as a software. I hope you understood. So if you have any queries, please comment on the section. Today we are going to talk about fast Fourier transform. It is used in various applications, even in a circular convolution. So we can use this fast Fourier transform, which means a transformed version of our original signal. How the signals are differ from original to transformed version. So when we look at in the time domain, so we don't find some additional features about the signals. At the same time, when we move to the frequency domain, so we may find additional features like imaginary and real terms of the signals. Today we are talking about fast Fourier transform. So this is the program, fast Fourier program. As usual, CLC, clear all and close all, and we are going to display the fast Fourier transform. Here I am getting input from keyboard as enter the length and then input sequence in terms of matrix. So which means FFT requires two inputs, as L as a length of the sequence and X is the input sequence as a matrix, right? So remaining things are for graphical purpose. Okay, without delay we move to the programming. So this is our MATLAB command window once again. So here I have typed all our fast Fourier transform and then inverse for fast Fourier transform also. So once the Fourier transform, fast Fourier transform or Fourier transform has been performed, we have to retrieve our original signal back. That is why we go for inverse Fourier fast Fourier transform. So basic default function for inverse for fast Fourier transform is IFFT. For fast Fourier transform it is FFT. So both requires input signals. FFT requires length and then sequence. Here it requires only sequence alone. So if you want, you can change into Y, L also, but we have to be very careful about what is actually given in the input side. So what I have did here is I combine fast Fourier transform and the inverse fast Fourier transform as one program. I have given length 4 or 8, something like that, and then I'm going to give value for this input sequence, and then I perform the FFT. Y carries fast Fourier transformed version of X which is our input, and here I bring this Y in this IFFT, because transformed version of my X to be given as an input for IFFT. I hope you understood. I repeat, Y carries transformed version of my X, and in inverse fast Fourier transform I need to retrieve my X. For that, IFFT carries my transformed version of my X. This Y1 carries my original signal, same as X. Okay, and here is the plotting sections. and decoration purposes. Okay, so I'm going to run this program. See, I have displayed fast Fourier transform. My file name is FFT demo Raj. The first input is enter the length of the sequence. I'm going to give 8 here. Enter the input sequence. It should be inside the bracket. I have given 8 samples as an input to this FFT. Press enter. See, this is my output window. Here in this figure, you can see the 4 subplots. First subplot represents my input, that is X, and then this FFT. Second subplot is output of FFT, Fourier transformed version of my input, and the third subplot is the input to the IFFT, as I said, and fourth subplot same as my input. I retrieved my input back. So these figures are representing phase and magnitude of FFT, and this is phase and magnitude of IFFT. Okay, so these 3 figures will give you whole idea about my FFT and IFFT. In the same program, I performed the FFT and the IFFT program. You can give any value here, and then you can change any number here. Length of the fast Fourier transform input value will be any number. Okay, so another way to run my program, so directly typing my directly I have typed my name of the program, FFT underscore demo underscore Raj. Here the length will be 4. I am giving 4, and input sequence is 4 here. See, this is my input value and transformed version and input to the IFFT, and finally I retrieved my original value again. So I hope you understood. It's a very simple program. So if you want to see the values of y and then y1, you can also directly put here. First of all, you have to clear all the things. Put y and enter, y1 and enter. So this is the transformed version value. So this is my input value, right? So I hope you understood. Thank you very much for watching this. We'll meet again.